I guess the genesis of this talk, and this is just a nuts and bolts talk, how-to kind of a thing, but I think the genesis of this began in 1994 when the DNR started doing some mapping of spawning habitat with relation to winter navigation, and my data set starts there. And then Mark Evener's crew was doing a whole lot of work there over the years monitoring this population of Cisco, and finally we reached the point of deciding, because the Lake Huron Technical Committee identified it as a priority, Cisco restoration, let's see if we can figure out how to culture these guys. And so, you know, if you live long enough, what comes around goes around. You get to do things twice. Earlier in my career, I worked in the Great Basin, and we had this Cisco reintroduction project, or introduction project for Flaming Gorge Reservoir, which got lake trout in it. It wasn't supposed to, and now we had to feed them. So being in the upper Colorado River Basin, we were trying to find a species that wasn't going to get down the system, and we went with Bear Lake Sculpin and Bonneville Cisco, and tried introducing those to Flaming Gorge. The Sculpin project worked, the Cisco's didn't, but the long and the short of it was we were able to develop techniques for taking eggs from this unique critter. The Bonneville Cisco is endemic to Bear Lake, found only in Bear Lake, and it's easily sampled during the spawning runs. It's a shoal spawner in this highly oligotrophic lake that's on the border of Utah and Idaho. The objective was to stock about 1 million fry per year because we quickly learned they would not take starter diets that we could come up with. We tried them on live diets and so on. Finally resorted to just stocking fry. What I was hoping to do in the with this opportunity that presented itself on the St. Mary's River is to see if we could employ some of the same techniques we found with these, that they were easily cultured by egg incubating in walleye batteries, and then we had the feeling we could feed these things too based on the literature. So basically try about the same sort of thing. But here's our motley crew back in Bear Lake from, this is the Wyoming Game and Fish and Utah Division of Wildlife. And there were 2 Michiganders in this crew. One was holding the camera. Can you spot the other one?
I didn't know you worked in the 1800s.
Yeah, I've taken these things in black and white. You know, the publication I was taking them for wanted black and white, but it makes me look older than I am, I'm afraid. But there's Scott with his Proscopium enhanced headwear. But to Lake Huron and our Cisco issue here, we wanted to try some of the same things. The objectives were to develop culture techniques in a pilot level study that could be used ultimately for perhaps a reintroduction project for Lake Huron. And these are my objectives, but really the only thing we really played with was spawn collection, fertilization, and incubation. The rest of this stuff just fell out. That once you get them in jars, you rear them like they're walleyes, and once they're hatched, you feed them salmon starter diet. There wasn't much experimenting with that. So I'm going to focus on these 3 objectives: spawn collection, fertilization, and incubation. Incubation temperature. So spawn collection, our study site, because Mark's crew and our crew were already there, and we knew the location of a spawning site, we started working at Sugar Island. This is the location of the spawning site, and actually the location where we were able to sample running ripe females was very discreet in this area. There's nothing magic about Beta Wasi, this is along the west shore of Sugar Island, except that there was no current in this site. Substrate didn't seem to differentiate that much where we found spawners and didn't, but it was this exact site, and it was a very lacustrine type of environment in a river. The trouble with it was a long ways from the nearest access point, and because of disinfection and fertilization requirements, we couldn't really mount. We tried mounting this thing on a boat, but the weather was so rough we couldn't get to the fish with the egg-taking facilities. We had to bring the fish to the egg-taking site. This was a problem, a 4.5-mile trip in what can sometimes be really terrible weather there in November. And the result was, when you were transporting these fish in rough weather, they were almost always dead by the time they got to the egg-taking location. So what did we learn? With respect to spawning date at the site, our experience went back to 1994. We sorted through the information we collected over the early navigation study and this particular pilot study, and found that peak spawning was driven more by date than temperature. We had cases where temperature was certainly down there where it should be, and they still didn't spawn until this date window was open. And the peak dates were pretty narrow, and this is not true for other locations, I understand, but for the St. Mary's River, it's between November 7th and November 19th. And I understand other more lacustrine spawning sites are much broader windows and later in the year, but this is what we found in the St. Mary's. We figure this element for the study is complete for this location. The spawning site, we've identified exactly where it is, and that there are very few locations where you can find running ripe females. You can get males all over the place, but finding the running ripe females, the site is very discreet. And this area is capable of producing, we think, 1 million eggs a year without any serious problems to the population. But if you're looking at rehabilitating Saginaw Bay and Thunder Bay, you probably need more eggs than that, and we're not sure that this is the genetically the broodstock we'd want to stock in Lake Huron. We already have the nearshore types in Lake Huron. We don't have the offshore morph in Lake Huron, and these are a nearshore or riverine morph, so maybe they're not the thing we want in the main basin of Lake Huron. But anyway, for this site, in this case, about 1 million eggs per year, I think, is a safe bet. As far as sampling gear goes, we used a combination of gillnets and trap nets. And gillnets killed most of the catch, which wouldn't be so bad, except we had to carry them a distance too. And by the time we got them to the spawning site, they were just mostly dead. And we'll talk about that later. With trap nets, though, they could hold green fish for up to a week. We tagged fish, put them in the trap nets, and resampled them as they staged up. And we didn't see any mortality of fish that we put back in these trap nets that were caught in trap nets. The traps were easy to fish. We really appreciated that factor in rough weather and cold conditions, but they were a bugger to set and to retrieve, especially in November conditions, which were generally below freezing. And the trap net catches were poor because miserable weather conditions forced us to set in the wrong ways. It's really hard to get a trap net oriented across the path of the fish when the wind's howling up the river at 30 miles an hour. So when you could set them correctly, they fished pretty well. They're just harder to set. We did not experiment with electrofishing. We would have liked to have. We'd also like to have had a large commercial source. We could have worked with commercial fishermen, gone on board, done the egg take there. I think a lot of the problems we had would have been solved. Fertilization, very simply, we used about the same methods we used for other fish. Nothing special there. Same with disinfection. We used our walleye, Chinook salmon disinfection techniques, and they seem to survive that fine. Here's the broad brush view of what happened. We took eggs in 2006, 2007, 2008. We were too late for 2009. We missed the run. And in 2010. But I think in 2006 and 2007, we were pushing things. We were there too early. And in 2007, when we probably had ample opportunity to get eggs, the weather was so foul that we had very few live fish to work with. We're going to be so what we're going to do is be focusing on really 2008 through 2011 work, because that earlier work suffered from poor quality fish. But if you look at the combined effect of the condition of the fish across these years, if the fish were dead on arrival, but what I mean by dead is they just weren't gilling anymore. They still had bright red gills. They looked good, but they had just died. We got almost no egg survival. If they were obviously more old, either if they were dead for 10 minutes or dead for 1 minute, it didn't matter. They just weren't usable. They had to be alive, and when we had live fish, we averaged about a 50% egg fertilization rate. But because in those early years, most of the fish we took were dead on arrival, we really only had these years, 2008 and 2010, to work with for the rest of this presentation. There we had a nice sample size to work with, and there we experimented with 3 different water temperatures at Wolf Lake Hatchery. After we brought them to eye up at 7 degrees, we put them into 3 degrees, 7.6 degrees, and 10 degrees. 10 degrees was Wolf Lake Hatchery's ambient temperature. And so when our chiller failed, they would go to 10 degrees and we would lose everything. But the moral of the story is 10 degrees is too warm, but they do quite well at just a little bit cooler temperatures. And that cooler temperature also produced a rapid growth and allowed us to get spring fingerlings of a size we wanted for stocking by June. To summarize what we've learned about culture and some of the things we did into the feeding and stock out period, for the egg take, the broodstock should be alive at spawn taking. They have to be alive at spawn taking. Trap nets are really good gear for holding live fish, but if we could do the egg takes on board on a commercial vessel, that'd probably be preferable. Free-flowing females, they have to be. If they're not absolutely free-flowing, there's a real cost in egg viability. And they survived the disinfection process just fine. We think there might have been some mortality, but nothing severe. Incubation, like walleyes in egg batteries. And the incubation temperature has to be below about 8°C. The optimal temperature for us to meet our stocking windows was 7.5°C. We were aiming for the end of June to have about a 3-inch fingerling ready. A reliable water supply of cold water, not really cold though, actually. About 7.5 degrees. We have one hatchery, like Thompson Hatchery would be ideal because its ambient water temperature is what we were trying for in our chillers. And as far as rearing goes, jar culture them as if they were walleyes. Once the fryer and raceways, we tried using them, culturing them in using basically Chinook salmon culture techniques, and at about an 80% density that we would use if they were Chinooks. We did not have a chance to experiment with various densities, and that's something that still needs to be done. We don't know what the optimal raceway density would be for the fish. But we fed them the same as Chinook fry, starting with Chinook starter diet, and had no problems there. That we had experienced very little mortality during that process. They also took the OTC laced feed well, and they marked well. Our quality control samples on all the fish we OTC marked them all, were always good or excellent. And then, for example, in 2011, we had one fish that was good and all the rest were excellent rated marks. And you can see the excellent on the left corner there. So the objectives of the marking part of the study we feel were met. And as far as stocking goes, they took trucking well. We had no significant mortalities when we trucked them from Wolf Lake Hatchery to Thunder Bay. There was no noticed post-release mortality. And we stocked them as spring fingerlings at about 81 millimeters, 3.6 grams, and late June, early July. The numbers look like this. Because of the poor egg quality we got in 2008, we didn't stock many, but we stocked 40,000 in 2009 and another 9,500 in 2011. Total of 55,700 and some fish. And as a postscript, we have had some recoveries. These 4 fish have been recovered incidental to other work we did. We didn't expect it with a low number of Ciscos we'd ever see them again, and these 4 fish have shown up in other work we've done around the lake. 3 during fall spawning assessments for lake trout, and 1 was during the spring nearshore study, or during the midsummer nearshore study that we were funded to do last summer. They were all mature and both males and females, and these are the location of the Cisco stocking site is shown there. It's that canal coming into Thunder Bay, and all 4 fish were collected in the vicinity of those. We have a reef restoration project going on there, and that CEM reef complex is a brand new reef we'd built, and one of them was caught there. Another one was on East Reef, which is a lake trout spawning habitat, and 2 others were caught right near the stocking site. And their marks look good. This is what they look like. So we were confident those were our fish. So, any questions?